Hello and welcome to the first tutorial series on HAROS, the High Assurance ROS framework. In this video, we will be going over the basic preparation and setup steps that are required to follow this tutorial, as well as the target ROS application that we will be using as a case study. I will be doing this on a fresh Linux virtual machine that's got nothing in specific pre-installed other than Git and Docker. To get started, let's visit the HAROS tutorials repository. And if you scroll down a little, you can see a basic description of the repository contents, as well as some instructions to get started using this repository. So let's start maybe by shortly browsing the documentation about the Fictibot system, which is the fictitious ROS application that we will be using as a case study. Fictibot, in short, is basically a small mobile robot. You can think of it like a sort of turtlebot or vacuum cleaner type of robot, a small mobile base with a bunch of sensors. In particular, sensors for bumping into objects, a laser scan, and some wheel drop sensors. In terms of actuators, it's basically got the wheels, and that's more or less it. You can see that in the remaining of this documentation, it also describes the ROS architecture of the various nodes that are included in this example code, as well as a diagram of the expected computation graph of this application in runtime. You can see that there are basically 4 nodes in this architecture: a safety controller, a random controller, and they both redirect their outputs to the inputs of a multiplexer node that assigns different priorities to each type of input. And then finally relays the given commands to the base driver that in turn sends back to the controllers the readings of the various sensors. Going back, we can see that we have detailed descriptions for each of the publishers and subscribers of each node and so on. And at last, we've got some deployment documentation as well, giving short descriptions for each of the launch files that we can find in this repository. What each launch file is supposed to launch in terms of the ROS system and the application. But this is something you can browse on your own terms and time. So let's get back to the main page and start reading on the installation instructions, which in this case is going to be based on Docker images. So let's get started with the installation of the Docker image to try out HAROS in this tutorial. And as I've mentioned before, this virtual machine already has Docker pre-installed. So then, of course, the first step is going to be cloning this repository. So let's start with that. I'm going to select a directory for this repository and simply clone it. Then move into this new repository and specifically to the Docker directory within. So let's get back to the instructions. The first step is to execute this build script that is already available in the repository. This build script is going to create the Docker image from scratch, and this is likely going to take a while, so we can speed up the process here just for demonstration purposes. And while it builds, we can go back to the instructions and check that the next step is to run the run script once it finishes building the image, which will start the Docker container with HAROS already available within it. Okay, after a few minutes, it's finished building the image. Now let's give it a try to the run script. It starts the Docker container in its own directory for the Catkin workspace, And as we can see, the first step is to run the catkin script that will build this workspace within the Docker container. Again, this can take a minute or two because it has to compile all the 50bot code. Shouldn't take too long because the code is rather small. Alright, now that it's done, we're going to source the workspace as is usual in ROS environments. And now we should navigate to the repository within this workspace and then try out the first script to see if everything is working as expected. After another minute or two, it should complete this initial analysis, and once it says it's got the visualizer server running, you can go back to your web browser and open a new tab on localhost on the port 8080. I've already got here a bookmark to make it easier to get there, and there we go. We can see the visualizer page, so everything should be working as expected. It's got here a package dependency graph, a number of metrics, a number of reported issues within the code that we should be getting to in the following exercises of this tutorial, or at least part of them, not all of these issues. And we've got here also a tab showing some models of the code, in this case computation graphs. Feel free to explore them, but we will be getting more into detail in the respective exercises. But you can see that it's got here some circles of various colors. The purple ones are ROS parameters, the white ones are nodes, the green ones are topics. You can see their names, you can see their types, and where they are connected to. You can change between different models associated with different launch files. And that's basically it for this initial demo and installation setup. You can terminate the visualizer server and try out also this arrows news command, which prints recent news about the tool. And alright, it seems that everything is working without issues, so we are ready to move to the proper exercises in this tutorial, which will be covered in the following videos.